All right, so we can continue on with the next section of chapter 4, which also involves a bit of more algebra review here. In this case, reviewing the log functions, the logarithmic functions. All right, so recall a log expression is defined as a log of x of some base a equals some value y. And recall the log functions are related to, oops, forgot to share the video. There we go. All right, so we call the log functions are in the form expression of log of x of some base a equals some value of y. And recall what the log function calculates here. The log function calculates the value that our base a needs to be raised to. So y represents the value that a needs to be raised to in order to obtain this number x. All right, in other words, to get x, we need to take this base a and raise it to some exponential of y. Okay, so let's review a couple of definitions regarding the log function. So again, logarithmic, which was shorthand as log, a logarithm, shorthand as log, means power or exponent. Okay, we're calculating the exponential value of the log function. Because recall, this log expressions, log equations, log function, what it does, it calculates, as I already mentioned, the number, or in other words, the power that is needed to raise our base a to, our base a by, to obtain a specific value, a certain value represented by x, okay? So what does y have to be in order to get this number x from this base a? Like say, for example here, suppose we want to solve the following log equations. All right, so suppose we want to solve for this first example, you want to solve log base 10 of say 1,000 equal y, okay? Now, one way to go about solving log expressions or log equations is to rewrite them as exponential equations, okay? So again, let's use a relationship between exponential functions and log functions to rewrite this log function as an exponential one in order for us to solve this value of y. So again, what this problem is asking us to do, it is asking us to do, in order to get 1,000, in order to get this value of 1,000, what should we take our base 10 here of and raise it by to get this output? Okay, so what should y be in order for base 10 raised to that value of y to give us an output of 1,000? Well, all right, so let's think about this. So 10 raised to one number gives us 1,000. Well, we know 10 squared is 100, right? 10 times 10 is 100. 100 times 10, that gives us 1,000. Meaning that 10 should be multiplied with itself 3 times in order to get 1,000. In other words, 10 needs to be raised to the third power to get this value of 1k, which means that y has to equal 3. Okay, so log of 1,000 to base 10 equals 3. Okay, I'll just rewrite it here more formally. All right, so log base 10 for 1,000 equals 3. 3 is the exponent that we need to raise 10 by in order to get this out, in order to get this value of 1,000. All right, keep checking Zoom so it doesn't freeze on me. Let's do another problem here. Suppose we want to solve for this next example. Say log base 5 of say 125 equal y. All right, so once again, we write this as an exponential expression to help us solve for y. All right, so here we want to take 125 equals 5 to the y. We want to figure out what y or 5 has to be raised to in order to get this value of 125. Well, again, 5 times 5 is 25. 5 squared gives us 25, so it cannot be 2. Let's try to the third. 5 times 5 to the third. 5 times 5 times 5. 25 times 5. That gives us 125. So in order to get 125 from a base of 5, we need to take that base and raise it to a third power, which means that y has to equal 3 once again for the second example. All right, so thus the log of base 5 of 125 equals 3. Okay, let's do one more example of this type of problem. All right, let's do 2 more. All right, suppose for the next problem, we want to solve, say, log base 8 of 2 equal y. So log base 2 equal y here. Okay, so once again, let's rewrite this as an exponential function. Say ref 2 equals 8 to the y. But in this case, notice our value that we want to obtain is smaller than our base. If the value that we want to obtain is smaller than our base, then that means our exponent has to be some rational, has to be some sort of fraction. Again, let me just make sure. Okay. So how can we get 2 from a base of 8? What can we do to this number 8 here that will give us a value of 2? Well, what we can do here is what we call, I'll put this on the side. If we want to get 2 from 8, then the only thing we can do here is take the cube root of 8, right? The cube root of 8 equals 2. Or in other words, 8 to the 1/3, that's going to give us a value of 2. So in order to get this number 2 from a base of 8, we got to take 8 and raise that to the 1/3, meaning that y here has to be this rational, this proper fraction of 1/3. Okay. Let's just formally write it as well. In other words, log base 8 of 2 equals 1/3. Okay. So here we just did a little quick review of solving log functions, and usually to solve log equations, log functions, we rewrite them exponentials and then try to determine what our base has to be to obtain that value that we have here for x. I mean, not what our base, what our exponent has to be. What y has to be to raise our base to get this value of x. Okay. Now, so again, just a little quick review of log here. Before we focus on the main item, we're going to go get to section 4.3. Oops. Okay, now, so again, a couple more notes review here. I'm going to have to write it because there's no subscript in this app. All right, so for log base a of x equals y, we call the properties is that a, our base a here, has to be a positive value. X has to be positive as well. Y, that can be any number. But if we have a log expression and our base is 10 here, if our base a is equal to 10, then we recall from algebra, when the base is 10 of a log expression, we're dealing with what's known as a common log function. A common log function. And usually when we have a common log, so again, here we have a log base or log of base 10 of x equals y. Usually when we have a common log function, we can just write this as log x equals y. If the base is blank, we assume that the base is 10, the common base. Okay, so log base 10 is known as a common log function. But if our log, if our base of the log here, so let me write this again. Oops, there's a decimal here. Okay, but if our log function, our log equation, again, we have log base a of x equals y. If the base of this function is represented by our special natural number e, if the base a is a natural number e that we saw in the last section, that we reviewed in the last section, then what we're dealing with here is the natural log function. Then we have what's known as the natural log function, which will be the main focus of this section, the natural log. When we have a natural base, a natural number as our base value, right? That is our log will have a base e of x equal y. And we come from algebra. If the base of our function, if the base of our log function is e, then we denote that as ln of x equals y. All right, ln meaning natural log. Okay. So again, the natural log will be the main focus of this section here. Now, suppose, for example, we want to solve, we want to evaluate the natural log of 4 equals y. Meaning, in this case, we want to figure out, in order to get 4, what do we need to raise this number e by to get a value of 4? All right, so what does e have to be raised to get an output of 4? Now, recall from the previous section, e is approximated to be about 2.71828 and so on and so on, a non-repeating irrational number. Okay. Can you think of a number right off the top of your head? Can you think of a number that this can be raised by in order to get an output of 4? Not distinctly, we can't, right? We can't find a exact number to raise e by in order to get an exact output of 4. So how do we solve this? Well, to solve natural log functions, we gotta use our calculators here. All right, so to solve the natural log of 4, we go to our calculator, and every calculator has a natural log function. It's denoted as ln, which is right here, that big button right here on the left column, ln. So natural log, enter our value that we want to find the natural log of, which in this case is 4, to give us roughly about 1.3863. So natural log of 4, it's about 1.3863. 1.3863. 1.3863. Okay. Meaning that this is a number that we have to raise e by to get 4. So e raised to about 1.3863 gives us approximately 4. All right, let's double check that. So let's go back to our calculator here. And let's take our value of e, and e can be found right on the same button as ln. And in this case, to get e, as we saw from the previous section, to get e, we have to press second first. So second ln brings up e. Let's enter that number 1.3863. And e raised to the 1.3863 is approximately 4. So if we take that number e, raise it to that power, we get about roughly 4. All right, and these will always be approximations. It's going to be impossible to get an exact value for the power that we need to raise e by. Okay, so here we have verified that if we take e, raise it to this number, it pretty much almost equals 4. Okay, so let's do a couple more review here regarding the properties of the natural log, which also apply to the regular log function. All right, the following rules apply to both the log and the natural log. Oh, I have to sharpen this pencil. Okay, so oops. So it's going to be terms of the natural log, but these same properties also apply to regular log, to any base log function. Okay, so first property here. The natural log of 1, again, some algebra review here. The natural log of 1 is equal to, again, before we answer that question, what are we asking here? We want to see what number does e have to be raised by in order to get a value of 1. Well, any number raised to what power, raised to what exponent, always equals 1? 0, right? Any number raised to the 0 power gives us 1. So natural log 1 equals 0, since e to the 0 will be equal to 1. Okay. Second property. The natural log of the same base equals what? What do we have to raise e by to get itself? 1, right? Any number raised to the first power equals that number. All right, so natural log of e equals 1, since e to the first power will equal itself. Okay. What about, say, the natural log of e to the x? Okay. So what number does e have to be raised by to get e to the x? Again, what does log represent? Power. What do we have here? E to the power. So natural log of e to the x is just going to equal that power x. All right. Since if we take our base e, raise it to some power x, that's going to equal whatever e to the x is. Okay, or in other words, that's going to be using for solving equations, the natural log of e to the x. What essentially happens here is that the natural log and the e cancel out. So we have the same base as part of our output here. Those two pretty much just cancel out, leaving us with just x. And this is going to be useful for solving natural log equations. And similarly, for this fourth property here, e raised to the natural log of x, that's also just going to equal x. Again, when our base and our exponent is the same, they pretty much cancel each other out. So here we have e to natural log of x. The e and the ln, they essentially cancel each other out, leaving us with just x. Okay. But now some properties of mathematical operations with a natural log. All right. Let me just double check. Zoom's still working. Zoom's working. Okay, so property 5. Suppose we take the natural log of m times n. All right, suppose we're multiplying two numbers by one another within the same log expression. Well, again, what does log represent? Log represents powers. So here we're multiplying two values, two powers here. What do we do with powers? What are the root exponents when we multiply powers with the same base? What do we do with the powers? What do we do with the exponents? We add them together. So the natural log of m times n is going to equal the natural log of m plus the natural log of n. If we're multiplying two numbers over the same base, then their exponents, which is what we get from the log functions, then their exponents are added together. All right? Again, just a property for exponents. If we have a, let me see what I write this. Okay, there we go. If we have a, what letter do I use? A, I'll use little m. A to little m times a to the little n, then I equals a to the little m plus n. Okay. A similar case, if we're dividing, if we have the natural log of big M divided by little n, big N divided by big N. Well, again, using the rules of exponents, we're calling rules of exponents. What do we do when divide by the same base? What do we do with the exponents? We subtract them. So natural log of M over N is going to equal natural log of M, big M, minus natural log of big N. Okay. Now, what about, say, the natural log of 1 divided by big N? Well, let's use the previous property, number 6 here, and let's separate these two. So this will be the natural log of 1 minus the natural log of N. But as we saw earlier, what's the natural log of 1? Just 0. So this will equal 0 minus the natural log of N. Or in other words, the natural log of 1 over N equals the natural log, negative natural log of N. Okay, like a little example here. Again, rules of exponents. If we have 1 over x squared, that is the same thing as what? X to the negative 2, all right? 1 over some number. In order to get that reciprocal, then our exponent has to be some negative value. Okay, and our final property here. And that's taking a power to raising to another power. If we have the natural log of some number M raised to some power P, then we can write this as little p here times the natural log of big M. Again, using the rules of exponents here. If we had, like, say, x squared raised to the third, if we have a power being raised to a power, what do we do with those powers? We multiply them together. So this would be x to the second times 3, which gives us x to the 6th in this example. Okay, so we're using those rules of exponents, but in terms of the natural log. And again, these rules apply similarly to any base A. The log of any base 1 equals 0. The log of base A of A, if the base of our log is the same as our number here, that will always equal 1. And if our base is the same as the base, if our base A is also included in our number here, then that log and that base cancel each other out. But the main focus for this section will be the natural log. But these rules will also apply to any base A. Okay, so let me pause this video for now before we do a couple more examples involving the natural log.